message column to let me know if you do have any doubts. What we are going to cover today is geometry, and as simple as it sounds, lines and angles and triangles. And of course, this is going to be divided into sort of, I think lines and angles is going to take about 45 minutes of the session today, and maybe 15 to 20 minutes on triangles just today. So this is our agenda for today. But triangles is going to continue for at least another, I think, 2.5 hours. Triangles is a very big topic, huge topic. So after today, you're going to have an hour of triangles tomorrow, and at least another hour and a half the following week, in the next week. Yeah. And we are going to build, and I may ask you to do some reading on your own as well. So yeah, lines and angles, supplementary and complementary angles. What are supplementary and complementary angles? I would love to hear from you. What are supplementary and complementary angles? I'm giving you audio control. Feel free to say whatever you want to say through the audio controls. Also, if you don't have something to say, sorry, there's a lot of noise. If you don't have something to say, please mute the microphone at your end. Jay, I think your microphone is on. If you have something to say, good. If you don't, there is a lot of background noise. Yeah. We did part of it last time. I can't believe it. Sounds great. Okay. I thought we only did IR last time. I don't think we went into it. Okay. I thought you're okay. Nevertheless, we are going to revise. So, if you guys have done something with another faculty, I think we would have to revise because this is a new topic. It doesn't make sense to start from the middle. So, yeah, supplementary angles are angles whose sum. Supplementary angles are always in pairs. Yeah. So a pair of angles whose sum is equal to 180. And complementary angles are also in pairs, and their sum is equal to 90 degrees. Yeah, we will cover angle on a parallel lines in a short while. And this is just the basic concept that we will cover today: supplementary, complementary angles, angles on parallel lines and transversals in detail. And
so one angle cannot be supplementary angle, means a single angle. More than one, it can be more than 180.
No, one angle can't be supplementary.
Means the two lining joining and making.
So yeah, I will. Maybe I should drop here straight away. So angle around a point is 360, and angle on a line is 180. I think that is something you know. Yeah.
Yes, sir. It's a total 360.
This angle, even if I were to call this equal to theta, ये हमें इसकी value तो पता ही है 180, it's 180. But even if I were to call this as theta, this cannot be called as a supplementary angle, because supplementary, there is nothing like supplementary angle. Is supplementary angles. Supplementary angles are always in pairs. That is what I want to say. So like this. Let this be line L1.
It's a sum of 2 or 3 or more than that angles.
Not 3. Always 2. Pair. Pair is 2.
Okay, always 2. Theta, not even 4.
2. Not even 4. No. It's always 2 angles, and so for example, here you have theta and alpha on a straight line. Alpha plus theta can be said to be 180. Yes, I think that is clear to everyone. So theta and alpha therefore become supplementary angles, a supplementary pair. But that is how it is defined. That is the convention, Amit. I don't think there's a. It's not. Yeah, it's not. This is by definition. Now, alpha is known as theta's supplement. If two angles are supplementary, then they are known as each other's supplements. So alpha will be known as theta's supplement. I suspect you will never see these terms ever, especially in GMAT. But nevertheless, yeah, now that we're covering the basics, let's just cover. So alpha is known as theta's supplement, theta is known as alpha's supplement. Yeah. And similarly, so these were supplementary angles, theta, alpha. Not always found on a straight line, but on a straight line, if you have a pair of angles, they will always be supplementary. I mean, there are other examples of supplementary angles. There are other examples of angles where the sum is 180. We'll see a lot of them today. And if, say, you have these two lines that are perpendicular to each other, let this be line L1, let this be line L2. If L1 is perpendicular to L2, I hope you understand all these signs, yeah? This is a sign for perpendicular. This is a sign for parallel. Let me know if you find anything new. I am assuming you understand very basics. I'm not going to jump onto anything complex, but I will start from the basics. But nevertheless, I assume that you understand these basic symbols. So if line 1 is parallel to line 2, clearly theta plus alpha or alpha plus theta is equal to 90. Again, in pair, these are known as complementary angles. So when the sum of two angles is 90, they are complementary. Okay? Okay. So angles around a point is 360. I think you understand that. Angles on a line is 180. Supplementary angles, as I just discussed. Pair of angles whose sum is 180. Complementary angle, pair of angles whose sum is 90. Angles on a parallel line on a transversal. Now, what's a transversal? Again, this is not a word you probably see in GMAT or even in CAT. A transversal is essentially any line that cuts a series of lines, that cuts at least two lines. So any intersecting line that is intersecting two or more lines is a transversal. So this is the transversal. Let me call this P1. And let this line be L1, let this line be L2. And by design, I've taken L1 parallel to L2. So one line intersecting two parallel lines, L1 and L2. What can you tell me about angle 1 and angle 2? So I've designated all the 8 angles formed here as angle 1, 2, 3, 4, 5, 6, 7, 8. What can you tell me about angle 1 and 2? Without a shadow of doubt, they are supplementary. They are on a straight line. Supplementary, absolutely. 1 and 2 are supplementary angles. What can you tell me about 2 and 3? Again, on the straight line, supplementary again. 3 and 4, 4 and 1 are all supplementary. 5 and 6, 6 and 7, 7 and 8, 8 and 5 all supplementary. Yeah. What can you tell me about angle 1 and angle 3?
Vertical opposite angle.
Okay, आप जो भी हैं, is that who's okay, Amit, let's give let's try to distribute, it's okay. Let's try to distribute this among everyone, and I think I would want you to use the audio in general, and that's a general message for all of you when we have something major to discuss. छोटी छोटी चीज़ों पे अगर आप मैसेज में डालना चाहते हैं, मुझे कोई दिक्कत नहीं है, बट छोटी छोटी चीज़ों पे फिर वो, क्योंकि ये क्लास के जैसा है नहीं, दिस इज नॉट अ टिपिकल क्लास. So if you have something big to ask or to add, please use the audio. Feel free to use the audio without permission, which is why I've given you audio control. If there is something small and if I ask a general small question, use the messages, the message bar. So thank you very much for that. And yeah, so 1 and 3, sorry, we were on 1 and 3. What would you say about angle 1 and angle 3? Equal. And what do you call angle 1 and angle 3 as? There's a term known as vertically opposite. Transversal, the line which cuts parallel lines or any two lines. If you have just any two lines, Amit. Then, and if they are not parallel, then they are intersecting lines. So if you have this line and this line, so they are automatically going to be intersecting lines. If you extend them, if they are not parallel, if you extend them, they will intersect, right? Only lines that are parallel don't intersect. So though transversal, this could be a transversal. Now what I'm making, this is absolutely a transversal. Transversal need to cut any pair of lines, need not specifically be parallel lines, but we generally don't use the term transversal for for intersecting lines. I think maybe because of the application, I generally haven't seen the term transversal being used. I don't think you'll see this term at all. This is just to establish common language. I am going to use like corresponding angles. These are again terms you'll never see. Corresponding angles, vertically opposite angles, alternate interior angles. This is what we'll see through this diagram, these angles, but you'll never see them in the GMAT or CAT generally. So, okay, so yeah, so vertically opposite angles, let me just write them as VO. Vertically opposite angles are equal. And we have angle 1 and angle 3 as an example, or angle 2 and angle 4, or angle 5 and 7, or angles 6 and 8. Yes? What about angle 1 and angle 5? Angle 1 and angle 5, what would you have to say to that? Angle 1, angle 5 are known as corresponding angles. Are they equal? Yes, they are equal. Excellent. Corresponding angles correspond to the same side of the line. They essentially lie on the same side of the line. For example, L1 on L1 and L2, you have 1 and 4 and 5 and 8 on the same side, on the right of transversal T1. But I mean, the one facing upwards is angle 1 and angle 5 on the right, and thus this becomes the corresponding angle, and these angles are equal. Angle 1 is equal to angle 5. Angle 4 is equal to angle 8. Is also a corresponding pair of angles. Could you tell me any other pair of corresponding angles here? 7 and 3, 1 and 6. Excellent. So that completes our angle 1 is equal to angle 6, angle 7 is equal to angle 3. Excellent, excellent, very good. What about alternate interior angles? Alternate interior angles. 3, 5, 4, and 6. Excellent. Alternate interior angles essentially are, angles that you would see in a Z. Angles enclosed in a Z. So this, I'm assuming this line is L1 is parallel to L2. So angles enclosed in a Z. So this angle becomes equal to this angle, L1 and L2 being parallel to each other. Or even if the Z were not look like a typical Z, but like this laid back kind of Z, this angle is equal to this angle. Yeah, these are known as alternate interior angles, which in our case means angle 3 is equal to angle 5 and angle 4 is equal to angle 6. I'll show you 3 is 5, 4 is equal to 6. Is that good? Is that good? What about adjacent angles? Not very often used, but adjacent angles have a lot of application. Adjacent angles are supplementary. Very good, Pranitha. So adjacent angles would not be 1 and 2, Rajat. Adjacent angles would be 4 and 5, or 3 and 6. So now when you have two parallel lines, the angles that sort of face each other, the angles facing each other are just an angle. So 4 and 5, they are not equal, they are supplementary. And I think it's quite clear. I should probably write this. Angle 1 plus angle 1 is equal to angle 5, and angle 4 plus angle 1 is equal to 180. It's fairly simple, but let's have a look. Why angle 1 is equal to angle 5? We just established that they are corresponding angles. We also established that angle 1 plus angle 4, so this is 4, is equal to 180. So if I were to replace 1 with 5, because they are equal, angle 5 plus angle 4 is equal to 180. So they form a supplementary pair. These angles. This is a supplementary pair, 4 and 5. Similarly, 3 and 6 is a supplementary pair. Their sum is 180. Yeah. You will find a lot of such questions. A lot of questions where you need to use this. We'll see a few questions today where this is important. So I hope you remember. We started about supplementary angles, and the four kind of angles we've studied right now. Very simple angles: vertically opposite, 1 equal to 3, 2 equal to 4, or 6 equal to 8, 5 equal to 7. All equal, corresponding angles equal, angle 1 equal to angle 5, angle 2 equal to angle 6, and so on. Alternate interior angles, the one that form the sort of interior of a Z, and adjacent angles that are supplementary. Any doubts here? Very basic, very important. Let me know if you guys have any doubt here. Okay, no doubts. That is very good. Excellent, excellent, excellent. Before we jump on to triangles, maybe we can solve a couple of questions. Maybe a couple of simple, really simple questions. So say this is a pair of parallel lines. If this angle, this is parallel, L1 is parallel to L2. If this angle is 70 degree, how much is theta going to be? How much is theta? Yeah, but you don't even have to think here. It even looks parallel. Psi, it's not 110. Have a look. It is 70. Yes, for the very simple reason, if this is 70, then this is also 70. And this is 70, theta is corresponding with this angle. Theta has to be equal to 70 degree without shadow of doubt. Yeah, is that clear, guys? Yeah, that's right. Very good, very good, very good. What about this? So let this be line. This is not exactly a line. So yeah, this line is parallel to this line. If this angle is, let's say, 60 degree, and I have another line here. And this angle is equal to 20 degree. So I'm explaining what I made. L1 is parallel to L2 is parallel to L3. They are three parallel lines. And this is another straight line, L4. Doesn't look like a straight line. You should believe that it is a straight line. Starting from this point of intersection of this transversal. Let this be point. Let me define. Let this be point B. Let this be point A. Yeah. If this angle is 20 degree, how much is theta equal to? This is theta. You have to tell me what theta is equal to. Okay. Not any other answer? Does everybody agree this is 40? Does anyone still have doubts on whether this is 40 or whether this isn't? That was pretty quick. It is 40. If L3 is parallel to L2 and this L4 is a straight line, and this angle also comes out to be 20, corresponding angles. This is equal to 20 degree. And since the whole, we just discussed, if this angle is 60, then as a Z, this whole angle, the complete angle is also 60, out of which this one portion is 20. Theta would have to be the remaining portion, equal to 40 degrees. Okay, very good. I hope you didn't have any doubts here. And on that note, maybe you can try this question. Where are the questions? Yeah. Any questions? Please try question number 1 and question number 2. This is question 2. Please just try question 1 and 2. You have a total of 3 minutes. I'll keep a timer. I will be keeping a timer from here on. Please try question 1 and question 2. So this is X. Abhay, you risk frustrating, to use a polite word, some people again today. I was about to use the word pissing off, but I will not use that word. One is not 71. Rajat, check your answer. Take your time, guys. You a minute and a half. Question 1 is 144. Yes. Another 30 seconds. 30 more seconds for question number 2. I am assuming that you understand that the sum of angles in a triangle is 180. That at least you would need for question 1. That you would need without a shadow of doubt. Okay, let's discuss. Time's up. Question 1. Any doubts, anyone? The answer is 144. I will explain. Okay. I've run out of words. Oops. Yeah, so we have 2 sets of parallel lines. I'm going to make this as... You have 2 sets of parallel lines here. And I don't think this is the exact diagram. No, it isn't. Something of this sort. This angle is supposedly 115 degree. This angle is 29 degree. And we know that AB is parallel to ED. This is AB. And this is ED or DE. Yeah? Now, AB being parallel to ED, I'm just going to extend this. And this is what you must do in all such questions. Apply what you know. There's this constant talk about this is the jargon that you shouldn't stay in your comfort zone, get out of your comfort zone, and so on and so forth. When it comes to maths and especially geometry, you have to find your comfort zone in the sense that you have to find what you know. So if you know that when it comes to parallel lines and other intersecting lines, then you could have made. So Pranitha, you could have extended transversal. That's also one way we could discuss how to do it. But the simpler option here could also have been just extending D, because you know about corresponding angles. Point number 1. So if this is 115 degree and I extend this whole line, let me call this point P. Surely PE, PD or PE is parallel to AB because it's the same line. I just extended it. And if it is parallel, if it's the same line, and these are 2 parallel lines, and this angle also happens to be 115 degree, corresponding angles. Yeah? And if you know this is 115 and this is 29, surely you can calculate this angle. You can calculate this angle. Or if you remember now that there is a property in triangles which says that the exterior angle, this is the exterior angle, is equal to sum of the 2 interior angles. So this angles, what did I call it here? X is equal to 115 degree plus 29 degree. Straight away property of a triangle. You will find the answer 144 degree. Yeah. If you don't remember this, not an issue, because then you can calculate the third angle and find X, which again happens to be 144 degree. Is the same. Yeah, is this good? Excellent, guys. Amit, what did you not understand? What's not clear here? Okay, sure. Oh my God. Okay. Yes, I didn't understand that. Why is yes? That is really cool. I'm trying to understand the lingo. Well done. Cool. Okay. Question number 2. Is question number 2 clear? Question number 2 happens to be 54. 180 minus 54. So 180 minus 54 would be 126. This is 126 degree. Is answer to question 2 clear? And this is very simple again. You've just seen AB is parallel to CF and this forms a Z. So this whole angle has to be 73 degrees. Yeah. If this whole angle is 73 and this little angle is 19, then the remaining portion, this portion, must be this must be 54. It's 54, not 52. Yeah, 54 plus 19 is 73. Yeah. So now x and 54, this and this form an adjacent pair. I hope you remember we had discussed, if this line, these two lines are parallel, then this angle and this angle, they form a supplementary pair. Their sum is 180. And we have a similar situation. One of our angles happens to be 54. The other has to be, the one on the top has to be 180 minus 54, which happens to be 126 degree. Is that clear? Any doubts here? Excellent, excellent, excellent. Why don't you also try question 7 and question 8? Very simple questions. Please try question 7 and question 8. This is 5a plus 5 degrees. Yes, Sai is getting back on the quick answer part. Okay, try 8. Please try 8. What's the answer to question 8? I think that's good. That is good. Any doubts in question 7 and 8, guys? Question 7, is 90 degree. The answer to question 7 is 90. And the answer to question 8 is 55. Is this clear? Any doubt in these two questions? Yes, in question 7, not in question 8. Okay, I'm assuming that you guys don't have any problem here. So let's jump to...
Sir, yeah, I'm missing something in question 7. Like, what is y? Like, I'm making some silly mistake.
What is y?
X plus 2y. Like,
y 2y is... 2y is simply some angle, so 2y degree. So
Okay.
since this is 2x degree, this is 4y degree. So my question is, what is x degree plus 2y degree?
Okay. Yeah.
Yeah. So it's simply, you see, if that is 2x, and this is also 2x.
Okay.
And 2x plus 4y is 180, so half of it. X plus 2y becomes equal to 90 degree.
Okay. Thank you, sir.
Yeah. Okay, cool. Yeah. Excellent. Then let's just jump back to question. No, not to question, to triangles. Let's start with triangles. I'm getting a repeated call from someone. Triangles. So, I think you should forget about what I've written here. Can you tell me on the message bar or through the microphone, what do you remember about triangles, except what I've written here? Yeah, so let me just open a new whiteboard for you guys. What do you guys remember about a triangle? How do you define a triangle? What makes a triangle? What is a triangle? Feel free to speak or to write. Pranitha, that's a very bookish but correct definition. So it is a closed polygon of three sides whose interior angles equal 180. Very good. Any other definition? It has three angles, three sides. I guess that's what you wanted to write, Amit. It does indeed have three angles and three sides. Triangle has three sides. Sum of angles is 180. Okay. Anything else? Anything interesting? Anything new that you would like to add to this? Okay. Yes. Sum is 180. Anything else? Exterior angle is sum of the two interior. Very good. The strongest shape in terms of architecture is the triangle. I'm surprised at that. Are you an architecture student, Pranitha? Strongest shape in terms of, I'm surprised. Okay, I'll Google what this means in terms of shape, the strongest shape. Yeah, but no, I think it distributes pressure equally. So most regular, like a tetrahedron. A tetrahedron is not a triangle. So a pyramid is a tetrahedron. Pyramids are other tetrahedrons. Distributing pressure equally has nothing to do with the triangle. Yes, I can look at pillars and stuff. I worked on pillars and stuff for a few years before I shifted to the education sector, and I have absolutely no interest in going back. So I'm sorry, I'm not going to take your offer of looking at pillars and stuff. But okay, something interesting that I got to know about triangles. Let me show you this diagram that I'm going to use throughout to explain triangles. The reason I use this diagram is a conventional diagram, is because I have assumed here, as we would normally conventionally assume, that C is greater than B is greater than A. So I've taken an enclosed side of straight lines, making three angles: angle A, angle C, angle B. As you can see, there's some, as you just told me, is 180. That is absolutely correct. But I've taken here that C is side C. So AB is equal to C in length. AC is equal to B in length. CB is equal to A in length. Yeah. And what I want you to remember from here, just to establish common language again, is if you have triangle capital A, B, C, where capital A, capital B, and capital C are vertices, then by convention, the sides opposite to them are known as small a, small b, and small c. So opposite to capital A, the vertex is the side small a. Opposite to capital B, the vertex is side small b. Opposite to capital C, the vertex is the side small c. Why is this needed? Because we are going to talk about a few rules. Needed to understand a few rules. Yeah. So if C is greater than B is greater than A, if you have a triangle of three unequal sides, then what I want you to remember, rule number one, that you may have read as this. This is the rule. Sorry, what is happening? Yeah. Sum of two sides is greater than the third side. Mathematically, the way you would need to apply this is that sum of two sides is greater than the largest side. So let me just write largest here as well. Yeah, so this is one rule, very, very, very important rule. In fact, the sum of angles comes out to be 180 and all is very good, but essentially, if you want to check if a triangle, if the enclosed figure is a triangle or if it isn't, then this is a property that is direct. You can immediately check if the sides make a triangle. So sum of the two sides has to be greater than even the largest side, and this also means that any side is greater than the difference of the other two. And I can also replace this any side with the smallest, with the word even the smallest side of a triangle has to be greater than the difference of the other two. Yeah, let me go back to the diagram to explain this. So if A and B are the smallest side, clearly I've taken A as the smallest side here, C as the largest. Then as I just mentioned, sum of two sides, sum of A plus B has to be greater than C. And if I were to take B to the other side, this is an inequality, we would get that even A is greater than C minus B. Even the smallest side is greater than the difference of the other two. Is that clear? Is this clear? Very simple, very, very simple. Nothing spectacular about it. Okay. Now, as far as application is concerned, what you should remember, in fact, maybe I should ask this. Which would be the biggest angle here? We have three angles, angle A, angle B, angle C. Which angle would be the largest? A would not be the largest, Rajat, it would be C, absolutely. So I want you to remember this. If you have three sides in order, if C is greater than B is greater than A, then the angle opposite C will be greater than the angle opposite B will be greater than the angle opposite A, which means that angle C will be greater than angle B will be greater than angle A. Yeah, which essentially means the largest angle lies opposite the largest side and the smallest angle lies opposite to the smallest side, or vice versa. The largest side lies opposite to the largest angle and the smallest side lies opposite to the smallest angle. Yeah, is this clear? Is this clear? Okay, I understand why is yes. Thank you, Amit. You will not need to write that again. Very good. And that also means if you have two equal angles, then the sides opposite to them are equal. Let me also show this through a diagram. Yeah. So this triangle ABC, AB is equal to AC. That is what these dashes mean. Then these angles opposite to these two sides. So the angle opposite to AB is angle C. The angle opposite to AC is angle B. These two angles will also be equal. Angle B is equal to angle C. Or I can say that angle ABC is equal to angle ACB. This is an isosceles triangle, although I will avoid using these terms right now because, just trying to make a point. Let's not jump to types of triangles just for the timing. Is this clear? Good? Okay. Sum of angles we discussed is 180. Sum of interior angles, clearly that's what I meant here. Sum of all interior angles. What is an exterior angle? We've already done a question on exterior angles. Again, let me explain that through this diagram. I have, let this be triangle ABC. I have three triangles, angle A, angle B, and angle C, and this is the exterior angle. This is what you should remember. This is not the exterior angle, this hole. For angle B, say, this hole is not the exterior angle, this is the vertex angle B. Exterior angle is always an angle that is supplementary. It is supplementary with the interior angle. So for angle C or for vertex C, the exterior angle will always lie on a straight line with angle C. So if you extend BC, the angle alongside C is the exterior angle, or if you extend AC, then this angle is also the exterior angle. This is also the exterior angle. Is that clear? I want you to remember this is very simple, but this is always supplementary, always on a straight line with the interior angle by definition. No, they won't be equal. Of course, they won't be equal. How can they be equal? Their sum is 180. If C here were to be 80, the exterior angle will become equal to 100. Those two exterior angles will be equal. Absolutely. In fact, if you were to have a look at this. This exterior angle and this exterior angle are vertically opposite angles. Yeah? So they are like this. You have one angle that is here and one angle that is here. Vertically opposite angles have to be equal. Excellent. So the important property for exterior angles is written here. And I've also shown you the simple derivation. Angle A plus B plus C is 180. And exterior angle plus angle C is also 180. So you can simply replace, if you were to subtract or equate, you would find that the exterior angle for angle C here is equal to angle A plus angle B. Yes? Simple enough? Simple enough, I guess, I hope. Okay, very good. That is very good. We're not going to jump to formula of triangles. We are going to solve simple questions. Indicate which of the following forms a triangle. So I'm giving you certain values for sides. You have to indicate which of them form a triangle and which of them don't, or which of the sides represent a triangle. So side number 1 is 8, 7, 13. Are these sides often equal? Are these sides of a triangle? 8, 7, 13. I saw a no somewhere. Pranitha, they are. Yes. For the very simple reason, it's very, very simple again. Is the largest side less than the sum of the other two? 13 must be less than the sum of the other two, which is 15. It is, and thus this is a triangle. Is this, does this form a triangle? 20, 27, 15, 13? Yes, very good. Does this also form a triangle? 29, 21, 8? No, it doesn't. 29 is equal to 21 plus 8. This is not a triangle. The second one was. 27 was less than 15 plus 13. Okay, so I guess you got a hang of this. Very good. Very, 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 very good. And maybe a question on exterior angles, or maybe I can jump to a question here. So these are good questions. Why don't you try question number 4? Question number 4 is a good question, not the easiest of the lot. Please try question number 4. And do remember in question 4, and I'm throwing you in sort of deep water here, angles opposite to equal sides are equal. So if FD is equal to BD, just doing this one for you, and if this angle is theta, then this angle also has to be theta. Because the angle opposite BD is theta, and since BD is equal to FD, the angle opposite FD, angle B, also will have to be theta. Please try this question, question number 4. The question hasn't mentioned anything of that sort, Rajat. So it might not be needed. FD and A are not parallel, no. Ooh, many answers. 80, 170. Another one says 100. Let's see. Should we try another question or should we wrap it up here? I will wrap it up here and we'll discuss this question, of course. And I don't remember the answer. I think it is 100. I think the answer is 100. And let's see why it is 100. So if FD is equal to BD and these two angles are theta, that much is clear, I hope, yeah? And similarly, if ED is equal to CD, then if this angle were to be alpha, this will also be alpha, yeah? Now, we need to calculate angle FD. This is the question. This is the angle we need to calculate. Now, in most such questions, the reason I had given this question or even question number 3 that we'll discuss tomorrow was so that you understand that if you have, on the periphery of this angle, you have two triangles, triangle FDB and EDC, and you have two angles, equal angles here, theta and alpha each. You should always try to, you should always start with the angle that you need to calculate. So FD, you want to calculate this question mark wala angle, then start with this angle. What do you know about the angles adjacent to FD? So FDB, focus on angle FDB and focus on angle EDC, these two. So what I mean to say here is, I have to calculate this angle and because this is on a straight line with the other two, what do I know about this angle and about this angle? I know that, can I say angle FDB, this angle is 180 minus 2 theta. Angle FDB is 180 minus 2 theta. This angle is 180 minus 2 theta. And in a similar vein, this angle is, this one is 180 minus 2 alpha. Why? Because in triangle FDB, you have two angles that are theta, and the third angle has to be, has to make a sum of 180, has to be 180 minus 2 theta. Again, in triangle ECD, you have two angles that are alpha. The third one has to be 180 minus 2 alpha. Is that good? Is that clear? And what we also know in triangle ABC, the largest triangle, we know that 40 degree plus theta plus alpha is 180. We know in the largest triangle, this angle was 40, this angle was theta, this angle was alpha. You can see from this very diagram, theta plus alpha would have to be 140 degree. I think that is absolutely clear. The sum of the three triangles has to be 180. Yes, is this clear? Okay. And therefore, if we know this, can I calculate this question mark wala angle? Absolutely. How? Again, since the sum of these three angles is 180 degree, I can simply say that 180 minus 2 theta plus the question mark wala angle. Let me just write it as a question mark. Plus 180 minus 2 alpha. This sum is without a shadow of doubt 180 degree. And if you were to just solve this, you will get the question mark wala angle is equal to twice of theta plus alpha minus 180. If you just rearrange these terms, the terms given, you'll find question mark wala angle, the one that you need to calculate, twice of theta plus alpha minus 180. Theta plus alpha is 140, so just substitute it here. So twice into 140 is 280 degree, minus 180 is without a shadow of doubt 100. Is this clear? Is this clear? Okay. Okay, very good, very good. Any doubts? Any doubts in this question? Okay, I'm so glad if you don't have any doubts. Can I explain the sum being 100? Where is the sum 100? There is no theta plus alpha is 140. See, look at this triangle, triangle ABC, the larger triangle. It has three angles. The largest triangle, ABC triangle, has three angles. One is 40 degree, the other is theta, the other is alpha. So 40 degree plus theta plus alpha would have to be 180. And thus, theta plus alpha would have to be 140. Excellent. So I'm going to leave you here with this slide that we are going to cover, that we are going to start from tomorrow, which is this. We're going to start from here, from the different formulae for area of a triangle. The first two are used a lot. 4 and 5 are fairly miscellaneous. 5 is totally miscellaneous. I'm going to explain what these 5 formula mean. This definitely is double miscellaneous. You probably never need this formula. And I think question formula number 3 and formula number 4 are miscellaneous, but not very miscellaneous. And 1 and 2 are very common formulae. We are going to, you can have a look at this. We are going to start building on this from tomorrow. And to kabhi sikha nahi, yes, but it is not so surprisingly part of GMAT because it's fairly simple and old formula. So what we'll cover tomorrow, we'll cover formula of triangles. I'm going to talk a bit about, it is known as, Pranita, absolutely, this is known as Hero's formula. 2 is known as Hero's formula. Herons, it's written as Herons, but you pronounce it as Hero's formula. And we are going to talk a bit about in radius and circumradius. And we are going to talk about some miscellaneous types of triangles, acute triangle, right triangle, obtuse triangle, some basic and important properties, and some really good questions for tomorrow. Yeah. Okay, that's it from my side. I will talk to you about the homework part and about the doubt part. That is something that I have to do, and I'll let you know. I'll get back to you on that. And till then, bye-bye, enjoy. See you tomorrow. Okay.